Yeah, good morning. Today we are going to discuss about a very interesting topic, that is multistage amplifiers. So, before discussing about multistage amplifiers, let us take a small example where the multistage amplifier is required. As every day we are in day-to-day life, we are generally face the meetings, that are public meetings where some political leaders are conducting, or else somewhere else where some of the coaching centers, and where the many people are gathering there. So there we can see the public addressing system. A person who is speaking from the far distance, all the gathering can be easily listened. So by using what, that is multi-stage amplifier. Actually, as we discussed in the previous unit about amplifier, what is amplifier? Amplifier is used to increase the amplitude of weak signal, that is the amplitude of the input signal. So here a person who is speaking for the far distance can be easily listened by all the people, those who are gathering there. How? By using the multi-stage amplifier. So the person who is speaking from the stage, from there the wire or wireless, through wire or wireless, can be connected an amplifier. So maybe around 100 meters, we have to place one more amplifier, which consists of amplifier circuit. That amplifier will increase the amplitude of the speaker's voice or signal to various places. How much long the gathering may be. So from all places, from that place to all the directions, we have to place the loudspeakers. Here, the public addressing system consists of generally three components. Those are microphone, amplifier, and loudspeaker. Microphone can be placed where the speaker has to speak out, and loudspeaker should be placed at different places where the gathering is there, in all directions where the gathering is there. In between these two, microphone and loudspeaker, there will be amplifier stage. So here depends on the gathering length, that may be 100 meters, 200 meters, or 1 kilometer, or sometimes 2, 3, several kilometers. So those many amplifiers are required in order to listen the speaker's voice without any loss. Okay, this is the main concept of the public addressing system. Here the public addressing system consists of several amplifiers. So we need to connect one amplifier to another amplifier through some coupling techniques. Here at the input stage, this is turntable, and these are amplifiers. This is loudspeaker. Okay, here turntable or microphone, whatever it may be. So this from microphone, here the speaker has to speak out. From here to this is single stage amplifier and loudspeaker. The next stage is second one, from the turntable to, that is microphone, to first stage amplifier and second stage to the loudspeaker. Whereas in the third one there are one, two, three, four, three stages of amplifier stages. So this is called more than single stage is called multi-stage amplifiers, multi-stage connection. Okay, from microphone to loudspeaker, if more number of amplifiers are connected or cascaded, then this is called multi-stage amplifier system. Here, from the microphone to first stage, there will be some increase in gain. Next, from the first stage of amplifier to the second stage, there will be some more gain will be increased, and so on. Depends on how many amplifier stages we have used, that much of gain will be increased. So at the loudspeaker, how much gain is required, that much gain can be provided based on the designing process. Okay, so on the after completion of this topic, the student will be understand the definition of amplifier and the classification of amplifier based on frequency, coupling, and period of conduction. As we have discussed in the previous semester as well as previous unit, what is an amplifier? What is the definition of amplifier? As we know, sorry, an amplifier is an electronic circuit or device which is used to raise the strength of the weak signal. The amplifiers that deal with input voltages of very small magnitudes are called small signal amplifiers. Okay, here for the amplifier, the signal may be in the form of voltage or current or power, whatever it may be. So, if the input signal is to be increased, the variable voltage, then that kind of amplifiers are called voltage amplifiers. Next, if the amplifier will increase the variable or signal current, then this is called current amplifier. Another one, the power. If the amplifier which increases the power of the input signal, then this is comes under power amplifier. So basically, all the amplifiers that may be voltage, current, or power, which will use it to increase the amplitude of input signal without changing its frequency. Okay, it should not vary the input signal frequency. It has to increase only the amplitude. Then only it can say the amplifier. Okay, so the basic definition of amplifier now can be defined as the amplifier is an electronic circuit or device which is used to increase the input signal amplitude without changing its frequency. This is very important point. Okay, here the classification of amplifiers, it is somewhat small lettering. The amplifiers can be classified on the basis of frequency of operation. How much frequency, up to how much frequency we need to amplify, that is frequency of operation. Next, coupling circuit, that is cascading from first stage to second to third stage, like that. So that is called coupling. So coupling circuit, based on the coupling circuit. Next, period of conduction, how much period, 0 to pi or pi by 2 or pi or 2 pi, 3 pi, etc. How much period of conduction, based on that we can classify. So there are three classification: frequency of operation, coupling circuit, and period of conduction. Let us see based on the frequency. Here A, B, C, D, E. There are five classification based on the frequency. So what are those? As we know, the DC amplifier. DC is nothing but direct current. So direct current means it doesn't have any frequency. Of course, the frequency is zero here. This is comes under DC amplifier stage. So actually, it doesn't have any frequency. Means zero hertz. This comes under DC amplifier stage. 0 to generally up to 10 hertz. That is very basic frequency. That is also called it as zero frequency, 0 hertz. So that comes under DC amplifiers. 0 to 10 hertz, nothing but 0 hertz. That is DC amplifier, direct current amplifier. Next, audio frequency amplifier, AFOs. So generally we know the audio frequency range is 20 hertz to 20 kilohertz. So 20 hertz to 20 kilohertz. This is audible to human beings. Okay, that is we. So the signal which we can audible or which we can listen is comes under audio frequency amplifiers. 20 hertz to 20 kilohertz. Next, more than this 20 kilohertz. That is third one. Radio frequency amplifiers. Radio frequency amplifier frequency range is 20 kilohertz to 100 megahertz. It comes under third uh, classification, that is radio frequency amplifiers, 20 hertz to 100 megahertz. More than this, that is intermediate frequency amplifier, IF amplifiers, that is 455 kilohertz around, plus or minus 1 or 2 kilohertz, that is 455 kilometers, that comes under intermediate frequency amplifiers. Next, fifth one, that is last one, video or wideband frequency amplifiers, that is 0 to 5 megahertz. Okay, of course, that is from first, second, third up to third. So that is also another classification. Wideband frequency amplifiers, 0 hertz to 5 megahertz. Okay, this is the classification of amplifiers based on the frequency. Okay, from 0 to several megahertz. Next, based on coupling. Based on coupling means coupling is nothing but connection of first stage to second stage or second stage to third stage and so on. This is nothing but coupling. This is also called as cascading. Okay, in electronic circuits, whenever we want to couple or we want to connect one stage to another stage is nothing but coupling or cascading. Okay, here that based on that coupling we have three classification, that is DC coupling, RC coupling, transformer coupling. DC coupling is nothing but direct coupling amplifier, means there there will not be any network between one stage to another stage, that is amplifier stages, one to second, second to third, third to fourth and so on. There will not be any components or network in between two stages is nothing but direct coupling. Next, RC, RC coupling, second one, that is the components must be connected between first stage to second stage or second to third or third to fourth and so on. There will be resistor capacitor combinations. The network consists of resistor and capacitor is nothing but RC coupling amplifiers. Third stage is third coupling third classification is transformer coupled amplifier. Okay, this is nothing but in between two stages of amplifiers there must be connected a transformer. If the transformer is connected in between two stages of amplifiers, then that is nothing but transformer coupling. Is it clear? Okay. Third classification is based on the period of conduction, means up to how much period the signal conducts. That is not, that is third classification, that is based on period of conduction. In that, class A, class B, class AB, class C. Class A operation, class B operation, class AB operation, class C operation. Let us see. Okay, here with respect to waveforms, we can easily understand the period of conduction. Sorry. Class A, the A in this slide, the A figure shows the class A conduction, B figure shows the class AB, C shows the class B, sorry, class B, D shows the class C. Here the red line shows the positive half cycle, white line shows the negative half cycle. That is waveform. The waveform is drawn with two colors, red and white. So the red line shows the positive half cycle, white line shows the negative half cycle. The upper portion is positive half cycle, lower portion is negative half cycle with respect to horizontal line. As a operation. In this, the output current or the collector current flows for the entire input cycle. Means by giving an AC signal or a sinusoidal signal as input to the amplifier, if the output consists of entire signal, okay, entire signal means, let us see the previous slide. Okay, this is entire signal, positive half positive half and negative half. If the output consists of positive and negative halves, that is entire signal, then this is called class A operation. The output signal or the output collector current flows for the entire input cycle is nothing but class A operation. This is nothing but the period of conduction is 360 degrees. Okay, 360 means positive half cycle 180 degrees, negative half cycle 180 degrees, total 360 degrees. So the period of conduction is 360 degrees in this. The efficiency of this kind of operation is very less. Efficiency is nothing but the production of output signal with respect to input signal. So this may be around 50%. Means in the output signal there will be some noise. How much noise? About 50%. Only the output signal consists of 50% of input signal. So the efficiency is very less, 50%. Sometimes it is less than 50%. Okay. The class A operation, the period of conduction, the output signal is looks like this. Means entire signal shows. Class B operation. So here the output signal or the output collector current flows for only half of the input cycle. Okay, not complete cycle, only half. That may be positive half, maybe negative half, depends on the designing, circuit designing. So the output collector current flows for only half of the input cycle. This kind of signal, if the output shows, then this is called class B operation. The period of conduction is only 180 degrees, half of the input signal. That may be positive half cycle, that may be negative half cycle. Here the efficiency is increased compared to class A, that is about 78.5 percentage. This is very much high than class A operation. Okay, this kind of signal will appear at the output of the amplifier. Here only positive half cycle shows. Sometimes we can also get the negative half cycle, depends on the circuitry designing. Next, class AB operation. Here the output collector current flows for more than half cycle but less than full cycle of the input signal. Means in between class A and class B. Class B only positive half cycle or negative half cycle, means half of the input signal, whereas class A full cycle. Okay, but whereas here if it greater than half cycle and less than full cycle is nothing but class AB operation. Okay, the period of conduction is in between 180 degrees to 360 degrees, less than 360 degrees, greater than 180 degrees, 360 to 180 or 180 to 360. The efficiency is better than class B operation. What was the class B operation efficiency? That is around 78.5 percentage. Now the efficiency of this kind of uh, class AB operation is little increased. Okay, here sorry, positive half cycle is same as the input, whereas coming to the negative half cycle, it is somewhat loss. Okay, this is greater than 180 and less than 360. Class C operation. The output signal or the output collector current flows for less than half cycle of the input signal. Less than half cycle means class B, less than class B. Okay. The period of conduction is less than 180 degrees, means 0 to 180 in between, but less than 180. 0 to less than 180 degrees. If the output signal is consists only 0 to 180 degrees, then this is comes under class C. The efficiency is increased here 90%, around 90%. So we can summarize these four. Okay, this kind of signal we can get class C operation. Means this is not full. Actually, it should start from here. It is somewhat less than the input signal. Positive half cycle is somewhat lost. Okay, this portion is lost. Okay, from these four, we can summarize the classification of amplifiers based on period of conduction. Class A, the period of conduction is 360 degrees. Class B, the period of conduction is only 180 degrees, half of the input signal, 180 degrees. Class AB, the period of conduction is greater than 180 and less than 360 degrees. Whereas class C, the period of conduction is less than 90 degrees only. Coming to efficiency, the class A is about 78.5 percentage. Class B is greater than this, that maybe approaches to 90 degrees. Class AB 90 percentage. Class C, this is greater than sometimes 90% also. Okay, from this above slides we can summarize what are the topics were discussed. What are those? First, What is amplifier? Next, what is the meaning of multi-stage amplifiers? And what is the meaning of coupling? And classification of amplifiers. So this we discussed with respect to one example, that is public addressing system. Okay, let us discuss the next topic, that is multi-stage amplifiers. Okay, what is the need of multi-stage amplifiers? And what is the meaning of cascading or coupling? Let us see. And what is the meaning of cascoding? Cascade and cascode. Cascade, CASCADE, cascode, CASCODE. This is the letters, the differentiation between letters A, O. What is the need of multi-stage amplifiers? What is the need? Here, the current gain or voltage gain obtained from a single stage transistor amplifier is usually inadequate for most of practical applications. Okay, this is an important need to cascade or to get multi-stage. And next, when the input or output impedance is not of correct magnitude for intended applications, two or more stages may be connected for matching purposes. Means sometimes in order to measure the output signal from a single amplifier stage, this may not be possible because of high resistance or low resistance. Okay, if you connect a voltmeter, if the output resistance is more, so this cannot be useful. This voltmeter cannot be useful in order to measure the output signal. There we need the output resistance must be low. In that purposes, we need to add one more stage which is having less resistance. For these reasons, we need to connect more than single stage. An amplifier circuit containing two or more stages connected in succession one after the other is termed as multi-stage amplifiers. Okay, is it clear? If more than single stage amplification is done, that is nothing but multi-stage amplification. Okay, the second stage should be connected after first stage. This is nothing but succession. Let us again read out. Multi-stage amplifier, an amplifier circuit containing two or more stages, more than two stages, connected in succession, is nothing but one after the other, is termed as multi-stage amplifiers. In these amplifiers, the output of each amplifier stage is coupled in some way to the input of next stage as shown in the next slide. Okay, here how it should be connected, coupled in some way by using different techniques. We have to couple or connect from one to another. Okay, this is the block diagram of multi-stage amplifier. Okay, here the input is given to from here given to first stage amplifier, and this is the second stage. In between these two, there is a mean of connection. This is nothing but coupling. Okay, next from second to third stage, there is another mean. There is it may be another mean. Okay, this is a coupling network. So by means of any way, if two stages are connected, that is nothing but coupling. Okay, the multi-stage amplifier may be connected like this. Here the input is given to the first stage of amplifier and the output is measured from the last stage. Here last stage is only up to third stage. Therefore the output is measuring from the third stage. In between first second there is a coupling network, and in between second and third there is a coupling network. Here the types of multi-stage amplifiers. The multi-stage amplifiers are divided into two. Those are cascade and cascade amplifiers. Cascade. Okay, there is lot of difference between these two, cascading and cascoding. Let us see. What is cascade amplifier? If the output of first stage amplifier is connected to the input of next stage through some coupling, then it is known as cascading or cascade amplifiers. In these amplifiers, in these amplifiers, all the stages as well as interstage coupling used are identical. Okay, here the main concept of cascading is first stage, second stage must be same. These two stages of amplifiers are identical. Then this is called cascading. Or second to third, these two are identical. Then this is called cascading. In the cascading, if all the stages, how many stages we have connected in multi-stage, all are identical, then this is called cascading. These amplifiers employ common emitter stage for amplification. Generally, the common emitter stages are used for the cascading purpose. RC coupling scheme means resistor and capacitor coupling scheme is generally employed for coupling all stages. The CE stages must be connected with RC coupling. The output is usually common collector stage. Okay, let us discuss why this. Generally, why we need to take the output is common collector. For the common collector, the input impedance is high, whereas output impedance is low. Coming to other networks, for common base and common emitter, the input is resistance, input impedance is low, output impedance is high. Whereas in common collector, this is quite opposite. Input impedance is high, output impedance is low. Therefore, for common collector, the output impedance is low. The common collector impedance is output impedance is low. Therefore, we can easily measure. Therefore, the output is generally taken as common collector stage. Block diagram of cascade amplifier. Here, see, the input is given to the first stage of common emitter amplifier, and the output of first stage common amplifier is connected to the second stage of the common emitter amplifier. Since the two stages are similar, therefore it is nothing but cascading. Okay, in order to measure the output, generally common collector is preferred. Why? Because just now we have discussed the common collector is having low output impedance, whereas cascade amplifiers. In this cascade is also a multi-stage amplifier. In these multi-stage amplifiers, each stage may be different from other, whereas in cascade, all the stages must be identical, whereas in cascade, each stage is different from other. For example, one stage is CE and other stage is CC. Then this is nothing but common cascade. Or one stage is CB and another stage is CE. This is also cascade. Whereas if both the stages are CE and which are connecting, this is nothing but cascade. If both the stages CB and these two are connected, then this is nothing but cascade. If both the stages are CC, if these two are connected, then this is nothing but cascade. If identical stages identical amplifier stages are connecting, is nothing but cascade. If one stage is differ from other stage, this is nothing but cascade. This is the main difference between cascade and cascade. Different types of interstage coupling may be employed. In this, last stage is usually the CB stage. Okay. From this multi-stage amplifiers, as we know how to calculate the gain. Generally, gain is calculated. How we can calculate the gain of amplifier? Generally, the gain is defined as the ratio of output value to the input value. If both are voltages, output voltage to the input voltage, the ratio of output voltage to the input voltage gives the voltage gain. If both are currents, then the output current to the input current, the ratio of output current to the input current gives current gain. So voltage gain generally represents with generally represents with capital A. So A suffix V. If A suffix V is taken, that is voltage gain. V stands for voltage. So A suffix V, this is represented for voltage gain. A suffix I, which is represented for current gain. So AV is nothing but voltage gain. So AV is equal to output voltage VO by input voltage VI. So here, if multi-stage voltage amplifiers are considered, then how can we calculate the multi-stage amplifiers gain? If AV1, that is voltage gain of first stage amplifier, AV2 voltage gain of second stage amplifier, AV3 voltage gain of third stage amplifier, or the voltage gains of first, second and third amplifier stages, then the overall voltage gain AV is given by AV is equal to AV1 into multiplication AV2 multiplication AV3 and so on. If more number of stages, more number of voltage amplifier stages are taken, so each voltage gain must be multiplied with all the remaining gains. So all the voltages must be multiplied and the product of each individual gain is nothing but overall voltage gain. Like this we need to calculate the voltage gain. Next, bandwidth. Generally we know what is bandwidth. Bandwidth is nothing but how much frequency of bands will be allowed through that network. That is nothing but bandwidth. So bandwidth can be calculated from the frequency response curve. So how can we draw the frequency response curve? We can draw the frequency response curve like this. Generally, the frequency response curve is defined as which is drawn in between gain to the frequency. Okay, gain should be taken on y-axis and on x-axis we should take the frequency. Okay, from 0 to infinite frequencies, what is the gain? As you know, generally gain is taken in decibels. The units for gain is decibels. Generally, the gain is the ratio of the same parameter, generally voltage or current. So output voltage to input voltage will be gets cancelled. Both the units are gets cancelled. Voltage by voltage gets cancelled. So there is no units. Therefore, it should be taken the logarithmic. So generally logarithmic of the ratio of voltages or ratio of current is nothing but voltage gain, current gain respectively. So here the gain units are taken in decibels, which is taken on the y-axis. The frequency is in hertz. So by calculating for each frequency what is the output voltage, and generally input voltage is constant, so the ratio of these two, and by applying the logarithmic, whatever the value you get, that is taken and that is considered by taking for individual frequencies, by drawing on the logarithmic graph you will get this kind of response. So this response is nothing but frequency response of an amplifier. Okay, from this frequency response, here general initially the gain is increasing, and afterwards after some frequencies around 50 Hz, from 50 Hz to 20 kilohertz maybe constant gain you can see in the response curve. So from this constant area, pick the highest frequency and pick the lowest frequency. This the difference of highest frequency to the lowest frequency is nothing but bandwidth. Let us go for the previous slide. Bandwidth of an amplifier. The gain is constant over a frequency range. The frequencies at which the gain reduces to 70.77 percentage of the overall gain. If the highest gain is 100%, then around 70.7 percentage of the maximum gain is known as cutoff frequencies. Just now I have shown highest cutoff frequency, that is upper cutoff frequency is taken as F2 and lower cutoff frequency is taken as F1. So the next figure shows these two frequencies. The difference of these two frequencies is called bandwidth. Bandwidth is now taken as F2 minus F1, maximum frequency minus minimum frequency, or upper cutoff frequency and lower cutoff frequency differences is nothing but bandwidth. This is very important factor to be discussed in the amplifiers, single stage or multi stage. Okay. So generally the bandwidth is defined as the gain, okay, the frequencies at which the gain is constant is nothing but bandwidth. Generally the constant frequency may maybe get around 70.7 percentage of maximum gain. You can see here. Okay, if it is the gain is 1, then from here to here maybe 70.7 percentage. Okay, 70.7 percentage. What is the range of frequencies? This is from here to here, higher cutoff frequency to the lower cutoff frequency. The flat response shows the bandwidth. The frequency response curve is defined as the curve drawn between gain versus frequency of the given amplifier. These three are the main important uh, parameters to be measured for each and every amplifier and overall multi-stage amplifier. Okay, with this, till now we have discussed about definition of multi-stage amplifier and the need of multi-stage amplifier and the block diagram of multi-stage amplifier and the classification of multi-stage amplifier based on frequency, based on period of conduction, and based on type of connection, cascading and cascading. Okay, and also we discussed some of the parameters which are associated with amplifiers, that is gain, bandwidth, and frequency response. Next one, after completion of this topic, the students will be able to learn or understand different types of coupling networks and what are the advantages and disadvantages of coupling schemes. In the previous class, we discussed about the need of multi-stage amplifiers and the types of multi-stage amplifiers. Here the need for coupling. Here we must use suitable coupling network between two stages so that a minimum loss of voltage occurs when the signal passes through this network to the next stage. Okay, this is very important. In the communication system, generally the signal should be passed through the networks. Okay, the network may be single network or multiple networks or many inputs and many outputs. So, in the entire communication system, the signal loss should be zero. We should get optimum value, maybe 100%. The efficiency may be 100%. Not exactly, we cannot get 100%, but maximum uh, efficiency we need to get. In that case, the coupling is the main important factor, plays an important role when we are taking multi-stage of amplifiers. Okay, the suitable coupling network should be taken in between one to another stage. Okay, what is the main important factor to be considered while taking the coupling? There will be minimum loss of signal or voltage while propagating one stage to another stage through the coupling network. Okay, this is very important. when we are taking the coupling network. It does not allow the DC output voltage of one stage to uh, another one stage to enter into input biasing circuit of the next stage. Okay, the DC, when we discuss about small signal, since we are discussing about small signal amplifiers, okay, it deals with only AC. So the DC signal will not be entered into one stage to another stage. This is very very important. Okay, for these two reasons, we need to select an exact coupling network. Okay, here the types of coupling schemes. According to our syllabus, we have three coupling schemes. Those are RC coupling, transformer coupling, and direct coupling. Let us discuss about RC coupling. Okay, in the RC coupling, the coupling network consists of only R and C, that is resistor and capacitor. Okay, if the coupling network consists only resistor and capacitor, then this is called RC coupling. So where the RC coupling network to be placed, that should be placed in between one network to another network. Okay, this coupling schemes and types of couplings, that is direct coupling and RC coupling and transformer coupling. These coupling networks and circuits and gain, bandwidth and frequency response curve, all these things we'll discuss in the next class. Okay, let us conclude now. Up to now, we have discussed about first what is amplifier, next what is multi-stage of amplifiers, and what are the coupling techniques, and the classification of amplifiers, and what is the need of multi-stage of amplifiers, and what are the different coupling techniques in order to uh, connect the two stages, and what are the parameters associated with amplifiers, that is gain, bandwidth, frequency response, etc. All these things we have discussed. Let us discuss the types of couplings, that is direct coupled, RC coupling, and transformer coupling in the next class. If any doubts you have raised, then mail me at naar37 at the rate gmail.com, that is nar37 naar37 at the rate gmail.com. Thank you for listening.